Welcome to Unit 3. Before we get started on our lessons and in our notes booklet for this unit, there is an introductory activity as usual. So this introductory activity is a little bit different than the ones we've done before. It's a little bit more concretely based in trigonometry because we already have a little bit of a foundation in it. So you are going to have 3 pages in front of you. One looks like that with a circle. One is a table that should be on the back of your circle. And then your second paper, your third page, is going to have the instructions. So you might want to tear this apart so that your instructions can sit beside you while you work on your unit circle and table. So you're going to need a ruler and a protractor for this. If you don't have those yourself, let me know. You can borrow them from me. And we'll start by measuring the radius. So you're going to get some sort of measurement there, maybe about 15 centimeters. I'm not actually measuring it. Okay, but remember that you're measuring your radius. So that is the distance from the center of the circle to the outside. And technically this is not included in our steps, but because it's listed specifically up at the top here, we are going to fill it in. Our radius can be measured from the center to any point on the outside of the circle. So you could follow any of these lines that are drawn in here for you, or you could even go from here all the way out independently of any of the lines that are drawn in already. But determine your radius. That's step 1 before we even get started on the instructions. So I'm looking at my instructions beside me, and part 1 is looking at this circle. It says mark the positive axis as x-axis as 0 degrees. So 0 degrees. And this is our positive x-axis because if we were actually to put our scale on here, we would always put the positive numbers there. Okay. From here, you are going to measure all the angles from the positive axis. So from here to here, from here to here, here, so forth. And make sure you include those axes. So make sure that this point does actually get measured as an angle. What will that one be? Oh, I'm thinking it's going to be 90 degrees. Remember that this distance here is also an angle, as is measuring all these what we call reflex angles, ones that go beyond 180 degrees. Okay, so take a second, pause the video right now, and measure those angles. Okay. I'm assuming you've measured all the angles, and I'm not writing them in, so you can't just cheat. You need all those angles measured. And you're going to need that for part 2 as well, so definitely make sure you've done it. No cheating. The second thing you're going to do is you are going to find the point where your angle touches the circle. So, for example, here, you're going to draw a vertical line, so use a ruler and maybe a protractor to make sure it actually is perpendicular to the x-axis. So we want this to form a 90-degree angle. We want it to be perpendicular. From here, we are going to measure these two sides. We already know this side because it is the radius. Okay, so we'll measure these two sides as well and write them in. Remember, I should have my angle, whatever that angle is, labeled on the outside here. Measure, have those points labeled. This is, I don't know, 10 centimeters and 5 centimeters. I'm totally making that up, so actually measure them. Don't just do what I've written. Okay, so you're going to repeat that same process for the next point and the next point. And then you're going to repeat that process over here. And you're always going to the x-axis, just for consistency's sake. Then you're going to do the same thing in quadrant 3. So again, that concept of quadrant 1, 2, and 3, and 4 came up in our last unit briefly. It's going to be very important to this unit. So we've got all of these lines drawn in. We're going to have some measurements written in. Even from my sketch here, you might already see some patterns arising. Okay, but I would like you to do that right now. Once you've got all your triangles drawn in and you've got all your sides measured and labeled, go ahead, take a second, answer the looking for connections questions. Or you can move on to part 2, but I recommend doing the looking for connections before you move on. So pause again, do the looking for connections questions. Part 2 is moving on to this table. You're going to record all the angles that we have on that circle on the previous page. So you might want to use your phone to take a picture of it so you don't have to keep flipping your page over back and forth. So we'll have 0 degrees. I don't know what those 3 were, but then I know it was 90 degrees. I don't know what the 3 were in the middle. Then I've got 180 degrees and so forth. So you're going to go all the way around your circle, filling in all your angles until you get to 360. Once you've got your angles filled in, you're going to fill in the rest of the table by calculating your sine, cosine, and tangent ratio values. So how that works is you're going to type in sine of 0, not theta, of 0 degrees into your calculator, and you're going to get some number. In this case, I get 0. I'm then going to type in not sine, but cos of 0 degrees. Oh my goodness, having some issues here today. 0 degrees, and that's going to give me 1. And then I type in tan of 0 degrees, not theta, because it already theta is implied, that it represents all angles. Okay, so we've got 0 and 1, and then I type in tan, and I also get 0. So those are my answers for that first column. Then I'm going to do it for this angle, and this angle, and this angle, and so forth. Okay, so that's kind of how that's all going to play out. Measure those angles, and then calculate their ratio values. From there, you've got some looking for connections questions relating to this table. So what do you notice about the values that show up in each column? How do they compare within the column, between columns? Look for any patterns that arise. Look for similarities. Look for things that maybe one doesn't match the other two. Okay. The second question is, what is the range of the trigonometric ratios? So I'm looking for all the possible values. Just like we talked about range in terms of quadratic equations in our previous unit, and we talked about our minimum and maximum, we're looking for the same idea here. And so you can even write it in interval notation. So for example, I could say that sine theta has a range of -10 to +10, if that's what I notice about my graph. If I notice that it seems to kind of go back and forth, maybe it seems to keep getting bigger and bigger or smaller and smaller, then remember that that would be -infinity if it's smaller, or +infinity if it's bigger. We use rounded brackets if we cannot reach that value. We use square brackets if it actually exists. Okay, so that's our second question. The third question is, how do the numbers that you calculated in this table relate back to the numbers you measured here? So you might want to consider what the definitions of sine and cosine and tangent are when you're making this comparison, and maybe do a little bit more math on the side to think about it. So definitely want to have your calculator around. Once you've gone through and done these connections, you're going to move on to the journal entry. So make sure you look for connections because that will make answering the journal entry questions a little bit easier. You're going to be able to go a little bit more in depth if you've actually taken some time to explore. So good luck with this activity, and once you're done it and you've written in your journal, you can move on to start the next unit.